Hello, this is Max Drake. I want to talk about Python data analytics and my electricity bill. Been getting my bill, and I just want to go through the bill at this point in time, just so we've got some fixed points to work from. The bill as it comes, it breaks down quite well in that it's got the morning, afternoon, evening and late periods and night periods, how many kilowatts you actually use at those particular times, and then the average cost through those periods. So if you see here in the morning, if you're doing from 7 a.m. to noon, it's 21 cents for a kilowatt hour, whereas in the evening it's 25 cents a kilowatt hour, and then at night time it's 17 kilowatts an hour. So they're trying to encourage you to spend move your electricity usage to nighttime. Well, obviously some things you can't, like in the morning you're getting up and having a shower and having your breakfast, so you're using energy, quite a lot of energy then, and in the evening you come home, you make your tea and you're tired, you're sitting down maybe in front of the TV because your body's tired, maybe you've got a heater on just to kind of feel a bit of comfort, so using a bit of energy through there. And so what they're suddenly saying, well, if we can shift some of the energy use through to nighttime, we can even out our load. So to motivate you to do that, we're suddenly saying, well, instead of paying 20 cents, we'll give you 3 cents if you go and spend your money then. So there's a suddenly, so you don't have to do everything, but can you shift some of your things into that particular area? Now the logic behind that is that if you're driving a car, if you're driving in town, you're doing stop and start at lights, you accelerate, you're trying to get into a different lane or something like that to maneuver to get somewhere else. You know, you're doing a lot of changing, speeding up, slowing down and stuff like that. If you were just using your car in town, you'd actually find that maybe at the end of a period of time when the tank's empty, that you've done something like 350 kilometres. You then take the same car, you're suddenly going away on holiday, you're cruising on the motorways, and you're cruising along, you're suddenly thinking, well, that whole tank of petrol, I've actually got 500 kilometres out of it because I've just got it onto a steady state and I'm just running and it's going quite smoothly. Because it's not actually changing all the time, you've got higher efficiencies. So this is what they're trying to encourage. So they're suddenly saying there's these peak demands when we've got to kind of get all of the motors up and start generating all this electricity. But if we can get a lot of the load so that we've got maybe 2 or 3 power stations which are running full tilt all the time, and then the peak stuff, we bring in these other or these other power generation things, and just to hit those peaks, that means we've got this steady state or a base level. And so that's what they're trying to reward you doing. So based on that, that's one aspect of the thing. So when we look at the bill, the overall bill is $26. But if you add up this column of the electricity consumption by day, and you add all that up, it only comes to $12.75. So that's less than half of the balance owing. So what's happening else? So there's some distribution charges. Now, there's 2 aspects. There's distribution, admin charges, metering, EA stuff, and then you get your gross charges. So your total gross is 22. So we're a little bit over 50% of our gross charges, and then we've got a GST or VAT or whatever you want to. So a lot of these ones here have a fixed element, and they have a variable element depending on your level of consumption. So all of these ones have those as well, and I've yet to quite figure them out. So I'm doing a little bit of reverse engineering. So one of the things I started to do was I started to go through and record. Initially I was just recording the different rates for the morning, noon and night, and I was just doing it weekly. I just kind of knew which one I got through, and I've got a conditional formatting with 2 colors on this. So if it's expensive or there's a high cost, like it's 30 cents here, and then low, if it's really low, it goes into the brown. So the red is high and the brown is low, and you can see sometimes I'm paying nothing for my electricity. So at this point in time, what it's saying is the reservoirs are full, and if you use power at night time, we won't charge you for it, because we've got to keep those generators running. So we've got to keep them running because we can't suddenly ramp them up at 7 o'clock in the morning. So we'll reward you by not giving you any money, by not charging you anything. So this is one of the things that they can do in those stuff. So obviously there's times when there's different types of generators. In New Zealand we've got a lot of hydro, So therefore that's dependent on rain. So that's a different behavioural thing. So when I started to do this, I started to do that, and I thought, well, that's only one part of the story. Now, initially, I used to have, so when I actually looked at my power overall, generally it was around this 70 to 60 to 70, something like that, as it was in those particular periods. But when the next part, I suddenly thought, well, when do I actually use the power? So we're looking at the kilowatt hours and when I'm using them. So obviously, these ones you're multiplying one by the other to actually get the total cost, which is coming through on these ones here. And when we look at this, I want to keep my bills away from the morning and the evening, because that's when I don't want to use energy, because that's when it costs the most, and I want to use them late at night. So suddenly when I look at it, when I look at my averages through here, so my average is 62 kilowatts a week, I'm using 16% in the morning, I'm using 58% in the evening. So the first thing that I actually did on here is I suddenly thought, well, what's that 58%? That's in fact my hot water heater. So I've actually just got a basic electric hot water heater that just heats up the water. And initially I just had it on 24 hours a day. So whenever I pulled some water out, it would actually feel it had to heat up the last little bit of water all the time, instead of actually suddenly saying, well, there's enough of a reservoir, the hot water is at the top, just use up what you need. So in the end, like, the capacity of my hot water cylinder is way more. It's for a 3 or 4 people household, and in fact there's only one person using it, so it's way over capacity, so I don't need to heat up all the water really, and I only need to heat it up for a sort of duration. So where most of my energy is actually going into my hot water heater. When I'm actually doing the cooking and the cooking in the mornings and the evenings, and then I'm using my computer and all of that sort of stuff. This is where these 16% and 12%. So that's 27. So less than a third is actually on those two high peak points in time, and almost 60% is at night time. So to a certain extent, that caused a behavioural shift for me to actually suddenly saying, well, I should be trying to move everything into the cheap phase wherever I can. But obviously you can only move certain things. You still want your breakfast at breakfast time, and the breakfast time is a cut-off at 7. So since I sort of I sleep poorly, I wake up in the night and I turn the hot water cylinder on, and then I turn it off the next time I wake up in the night time. Sometimes that might be for an hour, sometimes it might be for 3 or 4 hours. So sometimes I get one, but I'm using less power on this. Now I should put it on a time clock, and maybe one day I'll get around to that. But anyway, my usage, and again, some of this would have been in winter, because you can see the winter prices coming through here. Suddenly I've gone from about 73 kilowatts down to about in the 50s through here, or late 50s and 60s. So my average is about 62. So that's caused behavioural change, just seeing the data that I've got through here. So overall, my top one through here in the middle of the winter was $30. And now I've actually had a low one in the middle of summer for about $9 or $10. Now, another little example of this that I can actually see just on the data is that I went away. So I turned everything off. So the only thing running was the fridge and the freezers, and there might be a little couple of vampire things somewhere, but I turned off my router and stuff. So I actually found there was a base level through here where I found that I was only using, say, if I went away, my base level is about 7 kilowatts. So therefore, the amount that I can play with is about 54 or something, 55 kilowatts, where I can actually do changes or shift. Now, I'm not being able to cut off 54 or something like that, but I can sort of see if I can redistribute a lot of it into areas. And I think I've done a bit of that with the modification of behaviour. Now, I find having the data has been able to make me look at this so that I can actually see that I can modify my behaviour to do that. So I'm being a bit more careful. So my nighttime has been reduced down, and even some of my daytime stuff is actually reducing down in some of the areas because I'm more conscious of it. So like if I'm doing baking, I do baking after lunch and I won't do it in the morning. So there's certain things. And if I'm going to do a wash, actually generally I do the wash in the morning, just because it sort of works in with the rhythm of drying the clothes. So that's the data I've got. Now, the thing which I ended up, and the question which I asked myself is, okay, then this was just manually putting in the data and just looking at stuff and doing a bit of graphing. But basically, I was graphing these ones against each other. So each one of these points here is a line through here. So as you see through here, prices are going up at the end of January. I haven't got the dates down here at this point in time. But the interesting thing is here, you see there's difference in prices. So sometimes there's a big contrast between the nighttime, the evening price, and at the same time the evening price, the nighttime price is almost down to zero, whereas this is up at 30 cents. So there's a big difference through here, and at times like this there's almost no difference. So they're saying we're running reasonably evenly. We don't really want to encourage people to put more stuff on night because we seem to be running on average through there. But when there's a difference, a high difference, then obviously they're trying to encourage you to do this. But the question then suddenly says, well, it's too late. You'll now want me to do that, but it's gone past, so it's history. So I can't modify I can modify my behaviour now, but at this point in time, I'm suddenly seeing there's a peak difference. I'm going to modify my behaviour, and at this point in time, there's no advantage. The other thing is, there's a simple question that I want to ask: is my next power bill going to be more or less than the one before? And this is the problem. This is I've got the power bill from 2 weeks ago, so I know what it was, but I don't know what the next one's going to be, and that's the thing which is going to influence my behavioural change. Do I know what my next power bill is going to be? Is there going to be a hard demand? Is there what? So when we actually look at this electricity authority, the electricity authority data is quite interesting. There's 50 points or 50 substations of where they generate and charge things from. Now I actually only want one of those, so I can actually isolate that and just get one. So the one that I've got is in Central Park in Wellington, and this is the data that you've got. Now if I just zoom in on a little bit of data through there and look at it, it's actually data points for every half an hour, and you see it's changing every half an hour. The price changes. So how do I know what the average price is at a specific time? I've got to somehow even out that data. Now, I can get this data. This is the line chart. I can go into the data panel. I can go to the bottom and I can download the data. Unfortunately, it downloads all 50 sites for a month at half an hour intervals. So there's a massive load of data. So when I actually pulled that data up to begin with, and I pulled that data in, one has got 11 lines of header at the top, and then it's actually got about 65,000 rows of data, and it's got way too much stuff that I want. So when I actually get the script, I'm using pandas, and I actually just pull that file in, and the first thing that I actually do is I skip the 11 rows just so that I get the proper header on the thing, and I don't get all the rest of the blurb in the file, because I don't want to modify the file. Just want to download it, upload it into a data frame, start playing with it. I then shift things through to make the time, the date time, become your index, so that you can start looking up based on dates. And then the second thing is we look at the region. So what we do up here in the region, where's my region? My region is the one region that I want. So I then filter it out and I write it to a file, so that I'm not using the original data frame, although maybe that's an idea that I should. So I then write that to a file. Then I bring that in, and I bring it in into two different data frames with different start and end time. So what I can actually do is that if I just go back to this thing here, I've got my information from, let me just reset zoom, from the 2nd through to the 8th of March. So I've got the data from that. That's the bill that I've just got. Then I've also got, wherever it comes through, I've also got the next week. So I get the bill on the 15th, so I get it a week later. So if I wait a day, I've actually got the next week's actual information. So I can now suddenly say, with all these jumps up and down, is this one going to be less than this one? And it's very hard to visually see on this, although there's a little bit of an inference. There's more of these jumpy bits over the top of the line than there is in this area here. So there's an inference that this one is lower. But what happens when it becomes more gappy and less consistent like this? Is this one lower than this one, or is this one higher than this one? It's confusing. So I need to do something with that data. So the first thing that I need to do is I need to put them into proper bins. So I need to chop up the data into the nighttime, the morning, the afternoon, the evening stuff. Now, because the way the days are set up, and because I'm actually using dates as in clear days from midnight through to midnight the next day, I end up with from 0 to 7, which is my first night time, and then I end up with a nighttime 2, which is from 11 to 12 o'clock at the very end. So I end up with 2 night times. Now I could try and join them, but it's not really important. So I can then break this into a morning, afternoon, evening and late. So I can now break them into them, and then I can group by those ones through there. I can list all of the price index. Sorry, if we just come back into here. So the data that we've got the last one, which is the price, which is in dollars per megawatt hours, not kilowatt hours. I can get each one of those and just put them into a list inside the frame of those ones between the 2 dates is what we do. And then I aggregate the list and get the mean. So I get the average for those frames within that week period. So that does that. I then drop the list column, and then the mean column, I've got 2 different data frames, one for the first week, one for the second week, and they've both got a column called mean. So I've then got to rename the 2 columns, one mean 1, one mean 2, or AV1, AV2, doesn't really matter any difference. And then, in fact, I might try and do that. I'm going to go AV1 and I'm going to go AV2. Because mean seems a bit deep, but well, now I've got to go. Now I've got 2 I've got 2 data frames. Now I can join the 2 data frames together, so I can concatenate them, and I can join the data frame 1A and 1A2, which I've done the renaming with, and it's an inner join so that they match up. So I don't want to append one to the other one, or they just don't line up at all. I actually want them to actually be an inner join so that they're on the same row. And then I can actually create a 3rd column, which is called change, which is just dividing one of the averages by the other averages inside the certain time frame. And this is the result that you actually get down here. So if we just look at that inside of a spreadsheet, you can suddenly see this is the first week, this is the second week, and these are the average costs for kilowatt hour during that period. And it doesn't really matter how accurate it is inside the other one. Again, this is per megawatt, and we need to divide it by 1,000 to actually bring it to a kilowatt. But again, it doesn't matter because it's a ratio that we want to do. We want to see whether these ratios of these percentages are less than 100%, in which case the next week's bill will be less than the previous bill. If all of these are something like 110, 115, 120, then we know that the next bill is going to be higher than the previous bill. And we can sort of get an indicative price of what it is. And so we can just also sum all of those up and then just divide by 6, so these 6 columns here, to get an average overall of a weighted average of the thing, just to suddenly saying, yeah, your bill's going down. So that's just an indicator that you can do those sorts of pricing. Now, to a certain extent, because I've actually just taken all of these columns and give them equal weight, so it's sort of indicative. But then the next dimension onto here would be to allow these ratios through here. So we know the average ratio, so we know that 16% of the bill is from the morning, 10% is from the afternoon, 12.5% is from the evening, 2.5% is from there, and 58% is from night. We can then that will suddenly saying, well, this is where the costs are coming in, so this is roughly what your costs are. And within that, I can even go to the next step and look at all of these fixed costs or extra costs that we've got on site, such as distribution, admin and metering charges, etc. So we know that some of those have got fixed costs. So there's one of them here where I actually had an electricity bill that the actual production electricity purchase cost was actually 1 cent. So I actually got 53 kilowatts for 1 cent. But then I actually had distribution charges and all the rest. So my final bill was $9.90. So that's pretty much the lowest bill I can ever get. So I can never get a bill lower than $9 or $10. So given that information, I should be able to work out how much of the distribution is fixed and how much is variable depending on the amount of charges that I've got based on I don't know whether it's kilowatt use or whether it's actual dollar charge on those. So I've got to do some formulas to actually check those out and do some. So I must probably do them in Excel and then play around with them a bit more. And again, they don't actually have to be absolute. Again, they're just general enough. It's sort of reverse engineering. This is the data now. I know roughly what they should be doing. So do they actually fulfill what they do? As the exercise, way back time here, my one question was, can I look forward in time and see whether my bills are going to be higher and lower? This is a method to do it, but it only looks in a very short period of time. There is a lot more data in these ones here, is that there's forward markets and there's also retail and wholesale, so I need to check to see if there's a difference of what I'm doing, and I don't know if these have the same tables or not. I've just been working off these ones here, and they answer a very simple question. So further on, there's also questions which you can actually ask of something like here at night time, even during night time, because there's these hourly intervals, is there certain hours that are cheaper than the other one? Like at this one here, in the Haywoods, at 12 o'clock, or no, 11:30, it's $217 a megawatt hour. And at 2 o'clock in the morning, it's 97, so that's half the price. So maybe I should be putting my hot water cylinder on between something like 2 and 4 in the morning, or 3:30 or something like that. That's 2:30, so from about 12:30 through to 2:30. Is there a low point through there? So the only thing that you can do with that. Another thing to actually take this further is some long-term behaviours, and this is the thing. Each year is different, especially because it's hydro, so it depends on the weather. So if we look from here, September to January 18th, September 18th, January 19th, this is like a volcano. It goes up massively to 500. Whereas when we look at this September 19th to January 20, it sort of goes up a little bit and then slumps right down into January. Then when we look at the next one, September through to January 20 to 21, it's almost going straight. There's a little bit of a dip here, but not anywhere near as marked as that. Then when we look at the next one, we're low, and then we get this big drop. So that one tends to reflect a little bit on the behaviour through there. Then when we look at this one's quite flat. It's a lot lower than all the others. So there seems to be no consistent, there is some consistencies from the point of view of weather, but then some seasons might be colder than others. There might be some more problems with the lakes or with the hydro stations and things like that, or the amount of rain and things that suddenly start affecting where there are these differences in demands. So straight off, I feel as if I've had a win for the first time, that I've been able to do some data analytics, and it's been able to be useful for me as a tool to actually do simple modifications. Now, the price or the reward for this is very, very trivial. You know, some of them, if we look at the charts, I did have ones. I have had one up at 40, but this is over a year. So I've done this for over 55 weeks now, and my lowest has been $9, and my highest has been $30. So I've had one somewhere I was looking at from a previous year that was up at $40, but I haven't tracked that far back. I think I'm quite happy with what I've got here, and it does give an indication of seasons of when things are a bit lower. But this year has actually been a very, very wet year. It's been one of the wettest years on things, so the hydro dams have actually been very high. So I think that's why the prices are very, very low, as indicated down here, that it's very, very flat through here. So the fact that the hydros are still quite full means that hopefully the prices will still be low, and with the modifications of behaviours of suddenly I can predict a week out now and see what it is. But unfortunately it's a historic week still, so it doesn't help me modify my behaviour in the future. Now, if I did have that information and it suddenly says, well, actually there's going to be a peak morning demand where the morning in March, so April the 2nd or 5th or something like that, it's going to be really high. You can suddenly think, well, okay, then I'll have my breakfast at 6 o'clock in the morning. So I'm actually getting up for that. So I'm not actually doing that, or I'll actually have a cold breakfast. Or you can suddenly saying, can I alleviate for specific areas in doing that? Now, in some ways, it's sort of ultra focused on something that's a little bit trivial in a way. But as I said, this is the first time I've been able to get the data and make behavioural changes such that it's actually doing something beneficial for me. So I hope that's of interest to you. I'll I'll put this somewhere, and I'll put the code that I've got through here somewhere, and I'll maybe give one of these wholesale price trend things and put that in there so that you can use it as a tool, and I'll give a link to the website where this data is from. Now, this is New Zealand data, but as I said, it is more, I had a question and I was able to answer it using this particular data, and that is it of all of the exercises and things that I've done, I played with data, I've got results similar to what the tutorials say, but it has no relevance to me. It has no benefit to me. And this does have a benefit to me, so that's why I'm quite pleased with it. So I hope you found it of interest. Thank you very much for watching.